This conference will now be recorded.
So
This conference will now be recorded.
fine. So continuing from what we were discussing yesterday, today we will try to understand how Docker can be installed on a Linux box. Okay, this can be a Linux machine which is running on your VMware or Oracle VirtualBox, or it can be any Linux machine which is running on the cloud, whatever is convenient for you. Okay, I'll actually show you how Linux machines can be created very easily in very less amount of time using Vagrant. Okay, but that will come up a little later. As of now, I would suggest all of you to create a AWS account. If you don't have it, just go into the AWS sign up site, and here you can actually create a free account. Okay, this account is free for 1 year, and just sign in into that account. It'll, of course, it'll ask for your credit card information and all that. They'll deduct only 2 rupees from your account, and those 2 rupees would also be given back to you after 48 hours. So that's not a deal. For 1 year, it's absolutely free as long as you use the free services. Okay, so I will log in into my AWS account. That sign up, once you do that, activation will take something between 2 hours to 24 hours. So it's better that you do that account creation as quickly as possible. Now, those of you who are not aware of AWS, because our concentration is not on AWS here, it's primarily on Docker, I'll very quickly show you how you can create Linux machines on the AWS cloud. And of course, I'll send you these navigations also. What you need to do is go to this services section. And in the services section, you can click on EC2. EC2 stands for Elastic Cloud Computing. And we are calling them as servers. These servers are getting created in North Virginia data center of AWS. In fact, you can select any of these cities. Preferably, we always say that you select some region which is closer to us, maybe Mumbai or maybe Singapore. That would be a better idea. Okay, I have some problems with those regions, so I am actually doing it in North Virginia. And once that is done, you just click on instances. These are the machines which I have already created, but since we want to create a new Linux machine, all you have to do is click on launch instance and search for Ubuntu. I told you, you can take Ubuntu or CentOS or any of those things. Don't take Red Hat Linux, because Red Hat Linux supports only enterprise edition of Docker, whereas we are working on the community edition of Docker. Okay, so here you just go with the defaults. Just click on configure instance details. One machine is sufficient as of now. Click on add storage. That one machine is getting created with 8 GB of hard disk. Click on add tags, security group, and in security group just add one rule. Click on add rule, click on all traffic, and here you select anywhere. Okay, don't worry about these navigations because I'll give all those things to you. Click on that, and now it will ask you, when you're doing this for the first time, it will ask you to create a new key pair. A key pair is nothing but a security key which enables you to connect to the AWS Linux server, which is currently running in North Virginia. We are sitting over here, right? In my case, I'm sitting in Hyderabad. From Hyderabad, I want to connect to the AWS Linux server, which is running in North Virginia. So I have to select some key pair, create a key pair. I will call this as a Docker key. Okay, any name you can give for that key. Download key pair. With this, what is happening is the security key is getting downloaded into your machine, and in whichever machine this Docker key is available, from that machine we will be able to access the AWS instance. Okay, it's done. Now if you see, if you just click on launch, oh, it did not get created. Existing key pair, Docker key, click on launch instances, and then you click on view instances. It's as simple as that. So we don't need to worry about the burden of maintaining the machines automatically on the AWS data center. It can be created in just a matter of seconds. Once it is done, in order to access these machines, I mean, I'll just give it a meaningful name. Generally, the server, whether it's a Windows machine or a Linux machine where Docker is installed, we generally call that machine as the Docker host. You can give whatever name you want, but that's the naming conventions that we generally follow. The machine where Docker is running, you call that as the Docker host. You see, this Docker host has come into running condition. But where is it running? It's running in North Virginia. We are sitting in Hyderabad and we want to access that machine. How do you access? There is an interface. There is an interface called as Git. All you have to do is go into Google and download and install Git. Just say Git download. When you do this, click on the first link you see here, okay, and download Git for Windows. You'll get a setup file. Install it. Just say next, next, next. Git will be installed in 2 minutes. What is Git? Git is just helping like an interface using which you are able to access the Linux servers which are running on North Virginia AWS data center. So I will open my Git bash. Git bash is an application which gets installed once Git is installed. So you just open your Git bash, and in the Git bash we have to navigate to the location where the security key was downloaded. By default, all of you know that generally in Windows, anything you download will go into the download section. So I navigate there, and then here you identify which machine you want to connect to. This is the AWS instance. Just click on connect and just copy this SSH key. They are automatically showing you what is the command which you have to give in order to access that machine. So just copy that SSH key and paste it over here. Finish. With this, I should be able to go into the North Virginia data center AWS Linux machine that we have created. Just type yes over here. Finish. So Git is currently working just like an interface. For example, I want to open Facebook. I can open that Facebook either from a Chrome browser or a Firefox browser or anything like that, right? Similarly, we are accessing that AWS instance directly from a Git bash, nothing more than that. I think someone was trying to ask some question. Nothing? Fine. Nice. So what you see over here, friends, is just a Linux machine. It's no longer my Git, Ubuntu, whatever IP address you see is the Linux machine which is running in North Virginia. Whatever commands you give over here, these commands are getting executed in the North Virginia data center Linux machine. Okay, you see that is why the timing and everything is different. July 11th, it's midnight. Okay, 41 UTC is the time zone. Okay, so that's it. A Linux machine we want, anything is okay. If you are comfortable with creating Linux machines on VMware, you do that, except Red Hat Linux. You don't use Red Hat Linux, use CentOS or Ubuntu or anything. That would be better choice. Now, once it is done, I will go into root account. This is not a mandatory step. I just go into root account for my convenience. How do you install Docker? How do you install Docker? It's as simple as this. Go to a site called as get.docker.com. In this get.docker.com, what they have done is they have given a shell script whose the name of the shell script is get-docker.sh. The first thing you have to do is using the curl command. The first command, what it does is it will download the shell script into our Linux server. So simply copy that shell script, that curl command, and paste it over here. That's it. If you do ls now, do you see a file called as get-docker.sh got downloaded? Now the second command will simply execute that shell script. This shell script, what it does is it will check which version of Linux you are using, and based on that it will do the corresponding installation. It can be a CentOS machine, it can be a Ubuntu machine, doesn't matter, irrespective of the kind of installation. If you know shell scripting, you can actually see the script also what they have given, the complete script which is getting executed, which is responsible for identifying which version of Linux you are using, and based on that it will install Docker, it will do the necessary port opening, everything it will take care of. Okay, so just download that shell script and run this shell script within a matter of finish. It's done. How do you check? You can simply give a command docker -- version. You will see that the Docker version that is currently running is 18.09.7. That's the version that we have installed. So it was as simple as that. All you require is a Linux machine. If you already have Linux machines on your virtual environment, you open that and you do it. Otherwise, you just follow the navigations that I will send you, wherein a AWS machine can be created, AWS instance can be created. The AWS also is creating the same Linux machine, but it's running on their data center rather than we maintaining the burden of maintaining the Linux servers. The AWS people are maintaining it. We are just connecting to that machine and we are doing our activity. But always keep in mind, once your task is over, it's ideal, it's good that you close that machine, shut down that machine. Just highlight that, click on actions, click on instance, and click on stop. This will shut down your machine. Tomorrow again you can start it and you can continue. Okay, so that's it. Docker has been successfully installed on the Linux machine. We went to get.docker.com, copied these two commands, and it has installed. This will work on CentOS also. It will work on a lot of other flavors, Fedora, uh, many other flavors it will work on. Okay, so that's it, friends. This is how Docker is installed on a Linux machine. Now we will move into the different commands that we generally use. But before going into that, I just want you people to become comfortable with some of the basic terminology that we will be using very frequently starting from today's session. Okay, let me explain that to you, and then based on that we'll go into the list of the generally used commands. So please look at my screen. uh, the machine, whether I already told this, whether it is a Windows server or it can be a Mac machine or it's a Linux machine, in our case it's Linux, the machine where you are installing Docker, that server, we generally call that server as the Docker host. Yesterday I told you that if you want to install Docker on a Windows machine, compulsorily it should be Windows 2010 professional 64-bit version or 2016 server. Okay, any other older flavors of Windows, you won't be able to install Docker directly. Okay, indirect ways are there. On Mac, you can do installation of Docker. On Linux, there is not at all any issue, except Red Hat Linux. Red Hat Linux does not, I told you that there are two flavors of Docker. One is Community Edition and other one is Enterprise Edition. Community Edition can be installed almost everywhere. Enterprise Edition is a paid version. Okay, so if you're going with the paid version, you can install it on the Red Hat Linux server. So this is Docker host is just a machine where Docker is currently installed. In my case, it's a Ubuntu machine which is running on the AWS cloud. Okay, the next one, very frequently we use this terminology called as Docker images, and we also say Docker containers. Images and containers. Now, what is an image and what is a container? Let us see what the Docker official documentation actually says. The Docker official documentation says that an image is just a combination of binaries and libraries which are necessary for one application to run. It's just a combination of binaries and libraries which are necessary for an application to run. A running instance of an image is called as a container. Okay, now listen carefully. When I say image, let's take the example of your regular operating systems, Windows or Red Hat Linux or whatever. Generally, you take that image in the format of an ISO image, right? Let's say I want to download Ubuntu. I go to the Ubuntu site and they'll give you a link. When you click on that link, an ISO image will be downloaded into your machine. That ISO image I can burn into a CD, or maybe I can put it into a pen drive, whatever. And once it is bootable, next time you will see that with that ISO image, we will be able to create, we'll be able to install operating systems either on the physical machine or on the virtual environment, whatever it is. So ISO image, once it is installed, we call it as an operating system, right? Initially, we called it as image. Then once it is installed, we are calling it as a OS. From one ISO image, it is possible to do any number of installations. Similarly, in Docker, initially, all the applications are provided by Docker in the format of images. Once you download it and you start running it, you call it as a container. So a container is nothing but a running instance of an image, and any number of containers can be created from the images. Okay, I hope you are understanding. Initially, all these images are available in the cloud site of Docker, which you will see very shortly. And a few other terminology. Please see this. When you install Docker, which we have done just now, an application gets installed which is called as a Docker client. Internally, this Docker client is installed, and what this Docker client will do is we will learn a lot of Docker commands. Like there is a command called as Docker run, there is another command called as Docker build. All these are different Docker commands that we will be learning as we go with the sessions. So you give all these commands, and it is the responsibility of the Docker client to accept your command And what the Docker client will do is, it will take the commands that you are giving and it will pass these commands to a background process which is running on your machine, which is called as the Docker daemon. Okay, so you give a command, whatever command you are giving, whether it is the Docker run command or the Docker build command, Docker images, or hundreds of other commands, all these commands are entered in the Docker client, which means you can say, I mean, at our level, because we will be interacting with the GUI part, at our level on a Windows machine, the PowerShell itself is working like a Docker client, because you enter your commands, everything directly in the PowerShell. On a Linux machine, the terminal, the git bash is currently working as a terminal, right? It's getting connected to the terminal of your Linux server. That git bash itself will start behaving like a Docker client. So the responsibility of the Docker client is to accept whatever commands you are giving, and these commands will be passed to the Docker daemon, which is a background process. The Docker daemon analyzes what kind of command it is, and based on that, either these commands will be routed to work on Docker images. Some of these commands will be routed to work on Docker containers, or some of these commands will be routed to work on what we call as the Docker registry. We have something called as the Docker registry. This registry is again also of two types. One is called as public registry and other one is called as private registry. What is registry? Registry is nothing but the location where the Docker images are stored. Public registry is maintained by Docker and it can be accessed via hub.docker.com. So today we'll start working on this public registry. Private registry is something that we create within our own servers, and whatever images you upload into the private registry, only our team members will be able to access. I hope you're understanding. So, I mean, this is just some basic terminology which you have to be, because as I go with the sessions, we'll be using this terminology. It's good that you know. Registry is just a location where the Docker images are stored, and we can push our Docker images either into the public registry, and you will make it globally available to everyone if you push it to the public registry. Whereas if you push them into the private registry, only my organization team members who are having access on that server will be able to access it. We'll practically set up a private registry and all that, and we'll see how Docker images can be pushed. None of these things are theoretical. We will practically try to understand all these concepts. Okay, so this is some basic terminology. Now, once this is over, generally the practice that I follow, though it looks a little childish, what I generally do is, the first session we will try to wind up the major Docker commands that we generally use. I mean, what I'll do is I'll just tell you the high level purpose of what a Docker purpose of each Docker command, the important Docker commands, and I'll type all those Docker commands on my notepad. I'll send these Docker commands to you, probably some 30 or 40 Docker commands, and it would be really good if you can by heart those commands, because if you're comfortable with these 30 to 40 commands, believe me, 60 to 70% of Docker is over. 60 to 70% of Docker. You don't need to understand what that command is doing at this point of time, because as you go with the sessions, those things will become clear. But having a knowledge, I mean, if I say, how do you start a container, immediately that command should come into your mind. If that kind of clarity you have, things will become really easy. So if you have time, I would suggest that please just go spend half an hour or 1 hour on the document that I'm going to type over here and try to by heart these 30 to 40 commands, so that from tomorrow, whatever activities we are going to see, they will really become a cakewalk for you. Okay, so please look at my screen. We'll first start with working on Docker images. What are the different commands which Docker community has given for us to work on images? The first one obviously is, how do you download an image? To download an image, the command is Docker, simply say pull, and you give the name of the image, whichever image you want. If this image is available in hub.docker.com, that will be downloaded. Or if this image is available in our Docker local registry, the private registry, then also it will be downloaded. Okay. Similarly, if you want to upload an image, to push an image into Docker Hub. Okay, I'll send this text document so that you can actually practice all these things. Don't practice, I mean, no need to put these things, because we will be practically seeing all that. My intention is it's good if you can by heart it. To search for an image from my command prompt itself, it's possible to search for Docker images using a command called as Docker search, and you can simply give the image name. The next one is to delete an image from the Docker host. I already told you that Docker host is nothing but the machine where Docker is currently installed, right? So the command for doing that is docker rmi, and you can give the image name, or every image also have something called as the image ID. When you download it, you will see it. So you can either use that and you will be able to delete that image. Okay. Similarly, to create an image, there are lots of ways in which images can be created using a container. If I want to create an image from an existing container, my own image, the command I give is docker commit. We can give the container name, or you can give the container ID, and then you can give the new image name. With this name, a Docker image would be created. Okay. Similarly, you can create images from something called as a Docker file. To create images from a Docker file, the command that we use is docker build -t, and you give the new image name, and then you say dot. In this case, when I say dot represents current working directory. What Docker does is it will look into the current working directory, and in the current working directory, whatever in the current working directory, whatever Docker file is there, based on that it will create a image. Okay. And how do you see the list of all the images which are downloaded into your machine? Docker host is nothing but the machine where Docker is installed, right? So you can give a command docker images, or you can also give docker image ls. Both those commands would do the same activity. Okay. So these are some of the important commands that we generally use. Okay, I think there's fine. To delete all the unused images, docker system prune -a. This will ensure that all the unused images are deleted. To link an image with a local registry. Okay, we also call this as tagging. Docker these are some of the important commands that we execute on images. Okay, so it's not difficult. You don't require any background of Linux or anything to start off with Docker, because Docker is using its own set of commands. It's not based on the Linux commands. You create a Docker Linux container, and in that container, if you want to do something, obviously you require Linux knowledge. But to directly work at the level of Docker, it's not using any of the Linux commands. It's having its own set of commands, and irrespective of whether you are coming from Windows background or Linux background, when it's new to Docker, you have to learn all these commands. Okay. The next one is working on Docker containers. We'll start practically seeing how these commands work in a very little while.
Sorry, I have a question.
Yeah, tell me.
The command docker images or docker images ls will show the unused images as well.
It will show you the list of all the images which are present on your current machine, Venkatesh. It can
okay, that includes the unused.
Everything. When you say Docker pull and an image comes into your machine, whether you are using that image or it's just ideally sitting like that, irrespective of that, it will show you the list of all the images. That's it.
Okay, thanks.
Yeah, fine. So friends, working on Docker containers, this is more important for us because immediately we'll be starting our work with this only. I want to see the list of all the running containers. to see the list of all the running containers. The command is docker container ls. How do you see the list of the stopped containers? There is no command for seeing the list of stopped containers, but there's a command which shows you the list of all containers running and stopped. Out of that, I can execute a grep command and I can filter whatever I want, which we'll see. Okay, directly you don't have a command to check only the private images. Private images in the sense images which are tagged into your local registry. I mean, Sunny, directly Docker does not support such a command, but I can create something like this. I can say Docker images, and from this I'll say grep. For your local registry, you will give some name, right? So I will just give that word, local registry. I'm just giving local registry as an example over here, but once we start creating it, we might give some other name. So I'll just give that name of the local registry. Out of the list of images, it will pick up only those images which are present in the local registry. Okay, direct Docker command is not there, so you're taking the help of some Linux command to do it. Fine. To see the list of all containers. When I say all containers, what I mean is running as well as stopped. So the command for doing that is docker ps-a. This will show you all the containers. Out of this, you can put another grep scenario and you can see which containers are only stopped containers. But directly, we don't have a command for seeing only the stopped containers. Okay, the next one, to start a stopped container. You will see that there is a scenario. All these commands go in a particular flow and it becomes very easy to identify that after doing a little bit of practice. Docker start, and then you can give the container name, or else you can give the container ID. Okay, start. What is start? You stop the container, like shutdown. Okay, you stop the container and now you would like to start it again. So you give the docker start command. The container is already running and you would like to stop it. So I'll say to stop a running container. To stop a running container, the command is docker stop. Generally, all these commands start with the word docker. Until we, almost all these commands have follow the same scenario. To restart a container, docker restart, and you can give the container ID. To restart a container after, let's say, 20 seconds, then the command we give is docker restart -t. You give the time and you give the container name or the container ID. To get detailed info about a container, which means on which network it is running, what is the IP address assigned for this container, and all that, you can see docker inspect and give this. This docker inspect, generally what it does is it will show you the output in JSON file format, from where you can see what are the volumes which are attached. Okay, what is IP address, etc., etc. All that information will be available here. Is Docker create a new virtual network adapter? Yes, Rahul. Docker actually creates a bridge network internally. In Docker networking concept, we'll elaborate that. Okay, how it works and all that will become more clear for you. But yes, it has its own network called as the bridge network. Docker actually supports 4 types of networks, and we'll discuss that. The default network we call as the bridge network. Fine. So friends, let's quickly finish off the important commands so that I can pass this document to you. To see the ports that are opened on the container, the command is docker port, and you can give the container name or the container ID. Whenever a container is running, obviously it will generate some logs, right? You can give a command docker logs and you give the container name or the container ID. Okay, now After all these basic commands, which are okay, fine. Similarly, I want to delete a container. To delete a, deleting is just something like your formatting. No, Sunny, that is your requirement. You want to restart you are creating a script where you would say that you want to restart that container after a fixed amount of time. You can give that. So to delete a container, this is the command docker rm, and you give to delete a running container, docker rm -f. You have lots of containers and you want to stop all of them. This will stop all the containers which are running on your machine. Sorry. To delete all stopped containers. This is docker ps hyphen this is docker ps -aq. The docker ps -aq, what it will do is it will actually capture the container IDs. Okay, and then on that you are executing this docker rm command or whatever you want. To delete all containers. When I say all containers, I simply mean running and stopped. In this scenario, the command that we are going to give is docker rm -f $docker ps -aq. -f is forcibly, okay, even if it's running, that container will be deleted. It will be, so when you're trying to work on multiple containers or something like that, generally we use this. Now, the most important command in Docker, which we very frequently use, which is for creating containers. To create container, what is the command? This is the command for doing that. Docker run, and then you give the image name, or you can give the image ID. This is the command which actually creates a container. Okay, so you have an image which you downloaded from hub.docker.com and you want to create it as a container. Then you would say docker run. Only after that container comes into picture, only after that container gets created, then you can start it, stop it, restart it, delete it, etc., etc. But this is the command which is going to create the container, and this run command actually comes up with lots of options, and we will be seeing all these options practically. So it's just let's see what are those different options. The first option is the run command comes with an option called as --name. This is used when you want to give a name for the container. If you don't assign a name, Docker engine will by default assign some name. Okay, so I want to give my own name, so I'll say use to assign a name for the container. The next one is -it. What this IT will do? IT will open an interactive terminal in the container. Most of these containers that we see internally have some kind of Linux related shell. That Linux shell, if you want to open so that I can go into the container and I can execute some Linux commands over there, we can use -it. Use to open interactive terminal in the container. Okay, in fact, I and T are two different options. -i, -t, that is the correct way, but generally you will see everywhere they just follow the practices combining two different options, so they just give it as -it. I stands for interactive, T stands for TTY terminal. Okay, the next one, if I want to run this container as a background process, we call it as daemon or detached mode. Use to run the container in detached mode so that the logs of the container don't come on the screen. You don't see the logs coming, your screen would be free, but the container would be actually running. So -d is used for starting your container. in the background. -V, this is used for mounting volumes. See, I asked all of you to actually by heart these commands, whatever we have seen, right? Now, I know you people are working people, probably you might not really have that much time to do that, but at least if you don't have time to work on all these 30 or 40 commands that I'm going to show you, at least try to finish off this 24th command. Okay, because initially to start off, this is where we'll be starting off. The 24th command, along with whatever options I'm trying to give over here, try to remember as much as you can. Once this 24th command is over, still you have time, just try to look over the other commands, but this is vitally important before we can actually start off with something. Okay, volumes from, used to share volumes between containers. The next one is -P. This is used for port mapping. What is port mapping? See, when the container is running within a Linux machine, if the Linux machine wants to communicate with the container, there should be some opening, port opening between the Linux machine and the Docker container. That port opening will be suggested over here. Okay, which means, example, if I give something like this, 8080 linked with 80, in this scenario, you know what? On the right hand side of colon, what you have, that is the container port. And on the left hand side, what you give, that is the host machine port number. Always, this is the pattern. When you say -P, and if you give like this is the Linux machine's port number, the AWS Linux server's port number, which is mapped with the container port. This container port is fixed. Every container comes with a particular port, only that port you can give. Whereas the host machine port is your choice. You can give whichever port is available on your machine. Okay, so let's take a note of it. Here 8080 is the Docker host port. It's also called as the external port. On some sites they'll just use the word external port, and 80 is the container port, also called as the internal port. Internal port is not our choice at this point of time, but once you understand Docker file, you will see that even that internal port of the container can be modified. We'll see that later. As of now, just remember that on the right hand side of colon, it is the container port, and on the left hand side, it is the host machine port. Now you are confused with all this port mapping and all this, but still you want to do port mapping. Better option is you give P. P, what it does is it will automatically identify what is the container port. Every container comes with a different port, right? You take that, it takes that container port, and on the host machine, it will automatically map with some port number which is greater than 30,000. It won't ask you. Here we are explicitly saying you map 8080. In the case of P, automatic port mapping is done. We don't need to specify anything. Okay. So I'll say used for automatic. We'll see all these things practically, then things will become more clear for you. Okay, so don't worry at this point of time. Used for automatic port mapping, where the container port will be mapped with some port number that is greater than 30,000. Automatically it will do the necessary port mapping and all that stuff. Okay, so that's how the P works. Network, used to attach a network to the container, which means when the container is starting itself, you are saying that this container should run on this particular network. This is used to link multiple containers to create a microservices architecture. -E, this is used for passing environment variables. If you give this option, if the container accidentally stops, it will immediately try to restart it. tries to do if the container stops. I think yesterday we had a small discussion about this. I can put an upper limit on the CPUs, how many CPUs this container should use. If you don't put a limit, as we discussed yesterday, it keeps on, depending on the process which is running, it keeps on expanding. But I can put a limit and say that this container should not go beyond that. Hyphen memory. This is used for putting the upper limit on the amount of RAM usage. Okay, so these are some of the important options that we generally use with the run command. A few more are there. As we go with the sessions, we'll try to see them. And these commands are mainly related to Docker containers. As I told you, at least for today, if you don't really have time, try to work on the Docker, the 24th command. I mean, I'm not saying you practically do it. No, probably you won't be able to do it. There are lots of issues which will come up. I will show all these things, but I just want you to become comfortable. How do you assign a name for a container? Immediate clarity should be there. How do you assign volumes? The option is -b. So this kind of clarity, if you have, that's more than enough. We can easily manage with our work. Okay, these are the commands which are related to the Docker containers. Do we have any Docker manual commands? Sunny, we have Docker help documentation, and you know they have provided the help in such a beautiful way you can't really believe. For example, I can just say Docker --help. When you do that, it will show you after Docker what are the different options that can be given. Or else I can say Docker images, and then I can say --help. Or else I can say Docker run --help, which means now this help will show you only the help related to the run command. This help will show you the help related to images. This will show you the help related to regular Docker command. So for every Docker command, I can give that help. So it will show you the documentation related to at that level what you're supposed to do. All that information would be shown in a detailed way. So you can get all that information, and of course the official documentation of Docker Sunny is the best place for seeing all these things, because they did not do any kind of and generally if you look at the official documentation, it's thousands and thousands of pages of information. Docker is not like that. They have given you precisely the exact information that is required. Based on that information, you can easily start up. Even a beginner will understand what they are talking about. Just execute the same commands, you'll get a conceptual idea, clarity of how Docker is supposed to function. Okay, next. See, when you are executing any Docker command, Venkatesh, for example, and just trying to start a database, don't you think that database would be creating some logs as to what kind of activity is happening? Not only database, you take a Tomcat application. When you deploy a Tomcat application and end users are trying to reach the Tomcat, obviously the Tomcat container, when it's giving response, it will be generating some logs, right? So what is the usage and all that of the Tomcat? If I want to see, where else can I see? Obviously, I have to go into the logs. Any application, when it's running, when it's interacting with some kind of third-party agency, whether it's humans or some other applications, it generates some kind of logs. So I want to check it, what is happening on that container, how many people are trying to access that Tomcat container, what is the response time and all that. I want to see. All that information would be obviously present in the logs. So we take that. Or else that container is generating an error message, you're not able to reach that container. What is the issue you want to see? Where else can I check? All that information will be present in the logs. Okay, fine. The next one, container network Docker network commands. Docker networking. To see the list of all the Docker networks that are available. The command we give is docker network ls. It might be boring today's session, just dry commands we are typing over here, but it's before we can really proceed, it's good that you have knowledge of these 30-40 commands. So that's the reason we are spending so much time on it. To create a network, docker network create -- driver. Okay, which type of network? There are 4 types of networks that Docker supports. So that network type you have to give, and what is the name of your network? That name you can give, whatever name you want. To get detailed info about the network, whatever network we have created, I want to get detailed info. So I can give a command docker network inspect, and here I can give the network name, or else I can give the network ID. Already we have seen an option called as -- network, which allows you to assign a container to a particular network. When you're creating the container itself, you want to say that it should run on a network, you can give that. But already the container is running and now you want to move it into some other network, that is also possible. The performance related check commands generally always happen via the inspect command, Prasanna, and the logs. This is how it can be done. But when it comes to performance, that level of things come once we go into container orchestration, which we'll do in Kubernetes and Swarm. At this point of time, we are just taking very, very basic baby steps towards understanding how containers work. The performance related issues like load balancing and all those things, they happen at a high level, for which you have separate tools. Those tools like Swarm and Kubernetes have to be integrated, and then they have their own set of commands, not the simple Docker commands that we are seeing over here. To connect a container to a Docker network, the command is docker not network connect, and you can just give the network ID, and then you also give the container that you are trying to connect, which can be the container ID. Oh, 26. This is my 27th command. As we go with the sessions, you will see that there are lots of disadvantages also. Disadvantages in the sense, you will say, I want this activity to be done on Docker, and Docker does not support a command for that. Okay, lots of scenarios we can show. I said that I want to delete all the Docker containers. There is a command for that. But if you say, I want to delete only the Tomcat containers, or I want to delete only the Nginx containers, in that kind of scenario, Docker does not support any proper command to do that. Direct commands are not there. So that is where shell scripting or Python becomes an advantage. So though we don't combine that Python sessions with the regular sessions, because it becomes too time consuming. I'm not sure how many of you are aware of this. We will be having Python sessions generally on Saturdays, where first 2 weeks or so we'll discuss the basic Python scripting principles, how Python works and all that, and then using that Python knowledge, we will try to understand how we will do automation tasks on Docker. What your regular Docker is not able to do, how that can be done through Python. Practically with some scenarios and use cases we'll try to solve. I don't say it's mandatory for you to attend that, but if time permits, please try to attend those sessions also. It's good, because anyhow it's free. It's nothing that is charged, but that's not part of the course. So it's your choice whether you want to come or not. That would be done generally on Saturdays. So this will disconnect want to delete a network. Docker network RM. So these are the general commands that we use, which are related to Docker networking. And fine, I think I forgot a few commands in the list of container related commands. These are also important. This is actually 25th command, to open terminal in a container. These are very, very powerful features of Docker. So correspondingly, these numbers also might change. Just spend time at least on the Docker container related commands. Okay, these network commands and all those, practically we'll see that at a later point of time. We still have, okay, you can see that later, but just concentrate on the other things. This is working on Docker volumes. See the list of all the Docker volumes. This will just work like a cheat sheet where you can refer to the commands from one location to what is Docker volume? Sunny, I did not understand your question. Can you just elaborate it? So approximately some 35 or 40 commands we have, 36 commands approximately we have given, because 2 more commands we have added somewhere in between, right? So that's it. Just if you can spend some time trying to go through these commands, if at all, if you are really busy, at least try to go through the Docker run command. That will be extremely helpful. Based on these commands, tomorrow we will, yes, Prasanna, that's storage, external storage, which means even if the container is deleted, I want the data to be preserved on my host machine. Then we use this concept called as volume. Volume is just a external folder or a device which is mounted onto the container, and whatever activity you do in the volume, that will be preserved even though the container is deleted. Okay, we will go step by step with use cases so that that concept becomes more clear for you. Okay, so friends, that's it. These are the commands that I want all of you to by heart. Now I'll send this Docker file, this commands file to all of you. immediately start working on this. Okay, and as we have already seen how Docker can be installed on a Linux machine, the basic image related commands and all that, if you want to try, you can. Container related commands, you might face some problems. I have to show you all that practically. But the image related commands that we have executed at the top, what we have written over here, you can actually start off with that. For example, if I want to download an image, what is the command for doing that? How it will work? It's required in any image. I did not understand, Prasanna. Are you asking from where it will download the image or what? If that is the question, let me show you. See this. All I have to do is, because we have installed Docker in the root account, I am going into root, and the command for doing that is docker pull, and you give the name of the image. For example, I want to pull Tomcat. It will download Tomcat. From where it is downloading all this, these images are present in the cloud site of Docker, which is called as hub.docker.com. If you come to the cloud site of Docker, here you will find millions of images, millions of Docker images. You just go into the explore section, and here you see there are lots of images which are available. In fact, if you search somewhere, you will find the Tomcat image that I have attempted to download. I think it's already downloaded on my machine because it does not take much time. But in fact, you can actually search over here by going like this, or else if you don't have that much patience, directly I can specify the name of the image, Tomcat. And it shows that with the name Tomcat, there are 20,956 images. Out of those images, by default, the official image will get downloaded. Okay, so the image has been downloaded. How do you check? You will get Oracle also. You see Docker images. If I give, you can see that the Tomcat image has been downloaded. It seems this latest version of Tomcat was created 17 hours back. Okay, similarly, Oracle you want. In Oracle also you have Enterprise Edition. Some of them are available only in the Enterprise Edition of Docker. You have Oracle Linux, which is an operating system, Oracle WebLogic Server, Oracle Instant Client, Oracle Database Enterprise Edition. You see that? So all these images are available. Not only Oracle, you have MySQL, everything is there, including Enterprise Editions they are giving over here. Okay, so everything will be present in Docker Hub. All we need to do is search for that corresponding image and download it. So similarly, any other thing, I want to download Ubuntu. So I'll just say docker pull Ubuntu, and in just a matter of few seconds, that image is getting downloaded into my machine. Now, if you give the command docker images, you can see two images. One is Tomcat and other one is Ubuntu. Okay. Now we'll go more deeper into these commands and all that in tomorrow's session. But as a precondition, please, just forget everything what we have discussed yesterday. All that is not important. What we have discussed today, whatever commands we have seen, try to by heart as many commands as you know. Don't think that first of all you'll conceptually understand the commands and then you will automatically remember. That's not the way for practicing. Believe me, as a kid, don't you remember we were actually asked to by heart the tables? 5 5s are 25, 5 6 are 30. At that time in my first class, I never understood why 5 5 is 25 and 5 6 is 30. I just by hearted because my trainer asked me to by heart. But at a later point of time, once you go to second class and third class, you understand multiplications and everything, then you will clearly understand what it means. But even to understand those multiplication concepts that the trainer is teaching, first of all, I should have by hearted the tables, right? Same thing here also. Be patient. Just try to by heart that 30, 40 commands. Believe me, 60 to 70% of Docker will just become cakewalk for you. Until we reach Docker Swarm and Kubernetes, you will see that everything is just going with the same flow. Okay, so please do that. Tomorrow we'll see much more interesting concepts. Okay, so friends, we'll stop the session. Thanks a lot. And ideally, it's always good that you shut down the machines once your activity is over, or better still, you terminate the machine. Okay, so fine. Thanks a lot. We'll continue tomorrow. Bye, all of you.
Thank you.
Yeah.
Thank you.